We're going to talk quickly about distinguishable permutations. The number of n sub 1 are of one type, n sub 2 are of another type, n sub 3 given by the following formula, where I have right here n factorial in the numerator, and in the denominator I have n sub 1 factorial times n sub 2 factorial times n sub 3 factorial times all the way out to n sub k factorial, where k is going to represent the number of different types of objects in the grouping. So k. Now remember, when we say something factorial, we're talking about, for example, let's say 4 factorial. That's going to be equal to the sequence 4 times 3 times 2 times 1, which in this case would be equal to 24. And that's just an example of what a factorial is. So let's consider the following. Consider this group of letters. We're going to have 4 A's, 2 B's, and 1 C. We want to know from this, how many distinguishable permutations can I create? In other words, how many different unique values, or orders I should say, are there going to be? So first, let's understand that we have 3 different groups of letters here. And that we have 4 A's, 2 B's, and then a single C. So that means we have a total of 7 letters. This is the n in the formula. And that's going to be in the numerator. So already you can see that we're setting this up. If we're going to use this particular formula, we're going to set this up so that we have 7 factorial in the numerator, remembering that that's going to be equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. In the denominator, we're going to have 3 different factorials. Why are we going to have 3 different factorials? Because we have 3 different groups of letters. So this first group means that I'm going to use 4 factorial, which means 4 times 3 times 2 times 1. So I will put that down here in the denominator. I'm going to multiply that by this second group, which will be 2 factorial, which will be 2 times 1. And then I will multiply it by 1 factorial, since there is only 1 C in this group. When I calculate this all out, this is going to give me the number of distinguishable permutations. So there are a number of things to remember here. First, I can just go ahead and multiply it all out if I wanted to. I can use my calculator, which has a factorial key, but this is what it looks like. We have 7 times 6 times 5 times 4 times 3 times 2 times 1 in the numerator. Then I want to go ahead and break it up. The 4 factorial here is going to be 4 times 3 times 2 times 1. Then I'm going to multiply that by the 2 factorial right here, which is simply 2 times 1. And then finally I multiply that by this last one, which is going to be the 1 factorial, which is simply 1. Now, one of the things that you can notice here very quickly is the 4 times 3 times 2 times 1 in the numerator will divide out with the 4 times 3 times 2 times 1 in the denominator, which is going to yield 7 times 6 times 5 in the numerator over 2 times 1 times 1, which is simply 2. But then again, this 2 will divide into itself once and into 6 3 times, And I'll be left with 7 times 3 times 5 for this particular distinguishable permutation. So this whole thing is simply going to be equal to 7 times 3 times 5, which is equal to 105. And that's the basis for a distinguishable permutation. Consider the following example. Let's say that a dealer